Okay, my friends, so what I've done here is it's your first look at what's called a Monte Carlo simulation of an experiment. So we'll do more of these as we go through today. The idea is you don't have to have a physical die in front of you to analyze probabilities if you have the ability to observe one being rolled. So that's the difference between a theoretical probability where you actually count the sides of the dice versus watching a die roll, which is what we did here. Okay, so what we're going to do is we're going to repeat what we did in parts A through D above. The first one was, what is the chance of getting a 3? Well, we did that by counting the sides, but what we did here is we rolled a die 30 times. Now, it's a standard, fair, 6-sided die, computer generated, but he rolled it 30 times. So for A, the denominator is going to be 30 because we did 30 trials of the experiment rolling a die. How many times did we get 3? Let's see, not on the top. 2, 3, 4. I got 2. I got 2 on the bottom, the 2 3s. So the chance, the probability that I just observed of getting a 3 was 2 out of 30, 1 out of 15. What is that? 1/7 is about 14%. What is that, about 7%? So it's about 0.07, maybe 7%. Yeah, I'm not exactly sure if I rounded that correctly. Let's check. 1 out of 15. Ah, not bad. That is not what I thought it was. 0.06666. I didn't know that. Pretty close though. It's about 7%. Okay. What was part B? An odd number. Okay, so how many odd numbers did we get? 1, 1, 5, 5, 5, 1, 1, 1, 3, 3, 5, 1, 1. 13. We got 13 out of 30 odd numbers. I'm going to try to guesstimate what this is. 1/30 is going to be about 3 and some change. 13 of them is going to be 13 to 39. I'm going to call that 44%. Let's see it. 43%. Let's see how close I am. What did I say? 43? 13 out of 30. 43.3%. Sorry. It's Thursday morning. I'm getting into my coffee. It's starting to kick in. So that's about 43%. I'm pretty proud of myself for that one. That's 43%. Okay. Now, well, we'll come back to that in a second. C was 3 or greater. I remember this. 3 or greater. 6, 4, 6, 6, 4, 5, 5, 5, 6, 4, 6, 6, 4, 3, 3, 5, 4. So that's 17. 17 out of 30. I'm going to say it's 7% above 57%. Let's see how close I am. What did I say? 57%? Ha! 56.6. About 57%. Okay, and last but not least, 1 or 2. Since I'm going to use that complement idea. I like that. So since we know that the 17 of the 30 were 3 or greater, that means the other 13 out of the 30 have to be 2 or less, which is actually conveniently the same as this up here. So I could just look up at that and pull that number, or realize that these two go, this from 100% equals that. So there we go. Now, it asked E, do your experimental probabilities, what we just did, match the theoretical. So I'm going to remember the theoretical ones. I'm going to put them over here in pink. Theoretical. This one was about 17%. This one was 50%. This one was about 67%. And this one was the other 33%. They don't match. Some are close. For example, those are 10% off. Those are 7% off. 10% off. 10% off. But how do you measure close? I'm not going to answer that right now. We're going to answer that later in this course, I hope. And even if it's not in the 105 that is on the books, we'll make sure we answer that. It's a big part of Stats 243, actually, measuring closeness. We're going to lay the foundation for that in this course. But for now, read on.